Conceptual designs of Sargassum cleaning vessels developed during 2022 and 2023. After developing the conceptual design of the CSCA Euro integrated system, Sargasso collector Catamaran, which was selected to participate in the SNAME, Maritime Convention, USA, October 2021, we made the donation of the conceptual engineering project to the Mexican Secretary of the Navy, SMAR, in January 2022. During the years 2022 and 2023 we developed several new Euro state-of-the-art Euro concepts derived from the learning curve obtained and further researches. All new designs are based on the premise of continuous operation of Sargassum collection in conjunction with secondary transfer and storage vessels, complementary to the barrier systems. The initial project submitted to SNAME corresponds to a catamaran with two symmetrical hulls, which we named ATSargassum 1. The new conceptual engineering designs developed with ramps and conveyor belt feeding systems, except ATSargassum 3, include the ATSargassum 2, a catamaran with asymmetric hulls. ATSargassum 3, a trimaran. ATSargassum 4, also a trimaran. ATSargassum 5, a barge and tug. Barge with a double hull in the central body, a central stern section pivoting on deck, and a system of coupling to the tugboat from the stern. Tug-Barge Coupler system. ATSargassum 6, a deck barge and tugboat towing set system. ATSargassum 7, a self-propelled deck barge, that uses a scuttle system. For storage and transfer of the collected sargassum. ATSargassum 1, ATSargassum 2, ATSargassum 4, and ATSargassum 5. These vessels used for storage and transfer of the collected sargassum are a Euro hopper barge, a Euro design named Hopper 1, where sargassum storage baskets are stowed. ATSargassum 5 is a tug-barge coupler system. The barge with a double hull in the central body, with a central stern section pivoting on the deck and a coupling system to the tug-barge coupler at the stern. ATSargassum 6 and ATSargassum 7 used for storage and transfer of the collected sargasso 20 cubic feet containers for storage, which are open and reinforced in the top part, and are intended to be transferred in operations ship to ship in high seas. Further details of the new designs. ATSargassum 2 is an asymmetric catamaran both in cross sections and length. The main hull has the largest dimensions. The asymmetrical secondary hull provides an advantageous position for both the sargassum collection system ramp and conveyor belts, as well as for the storage Hopper 1 barge. This design will imply, in the case of designing with two main engines, that the engine, including the shaft and propeller, adjacent to the secondary hull will be of greater power, dimensions, than the one on the opposite side, in order to counteract the greater resistance and drift produced by the secondary hull. Alternatively, a third auxiliary engine of less power located in the secondary hull could be considered, keeping the main engines of equal power. We based this concept among other sources on designs from a Euro or Aspen Power catamarans. Start fresh to get the innovative boat you want, a Euro, aspenpowercatamarans.com, and on the design modification of the Chizuski Trimaran developed by Chizuski Design of Poland. ATSargassum 3 and the ATSargassum 4 are based on similarities and adaptations of trimaran hulls. Ocean Arc for aquaculture developed by Ocean Arcs Tech from Chile and RENA classified. A Euro E Mayflower, a Euro developed by Shuttleworth Design, MISIBS, and Plymouth University. A Euro E Astra, Euro designed and built by Shuttleworth Design. A Euro or Chizuski Trimaran, a Euro developed by Chizuski Design of Poland. ATSargassum 3, corresponding to a trimaran type hull, is a theoretical concept that would use only fishing nets of removable rectangular sections and a continuous compressed air injection system through nozzles inside each rectangular net section. The idea in principle is to generate a turbulent flow of suction, thrust, and engulfment of the sargassum masses inside the rectangular net sections simultaneously with the forward motion of the vessel. ATSargassum 4 takes a similar configuration with modifications to the background of the concept, placing the arms or structures of the connection sections between the hulls of the trimaran connected above the main deck, and above these the ramps and feeding belts of the sargassum collection system, allowing the location of the Hopper 1 below the system referred. ATSargassum 5 is a tug-barge coupler system. The barge with a double hull in the central body, with a central stern section pivoting on the deck and with a coupling system to the tug-barge coupler at the stern. ATSargassum 6 and ATSargassum 7 are Sargassum cleaning deck barges sized to operate with 10-20 cubic foot cargo containers without the roof and therefore reinforced in the top area, which will be moved transversely on the cargo deck of the barge on flat platforms with railroad-type wheels that roll on transverse rails that allow moving the containers laterally after loading them with the collected sargassum. ATSargassum 6 requires permanent tug support, and ATSargassum 7 is self-propelled with a scuttle system. Of the 10 containers required for maximum operations output, 9 are aligned in a longitudinal direction placed 3 by 3 transversely and 1 placed transversely at the front, and 1 more container can be added in that lane for a total of 11. Once loaded with sargassum, all containers can be transferred to a support vessel and replaced by empty containers. The barge must have a ballast system of integrated structural tanks for lateral ballast transfer for the transverse stability of the barge, avoiding heeling during loading/unloading operations. The use of cargo freight containers facilitates the transfer of large volumes of collected sargasso stowed in large 20-foot containers without the use of baskets, achieving a more efficient and economical system in the transportation of the collected sargasso to the final waste collection destination. Further innovative solutions. ATSargassum 1 Sargassum crushing system. We have introduced the variant of a Sargasso crusher system on board the ATSargassum 1 Catamaran prototype, complementing the collection system conformed by ramps, loading rollers, guiding screens, conveyor belts, and hoppers. Additionally, we have added the concept of net or cage, simulating the systems of fishing nets, for storage and final disposal of the crushed sargasso waste, which could be deposited in the open sea. Previous study and approval of the environmental authorities and competent organisms of the matter, otherwise on land as it is currently done, with the advantage of a higher compaction of the crushed sargasso, i.e. a higher stowage factor. Hopper barges new designs. We have made a modification of the design of the Hopper 1 adapted to stow inside the hopper a 20 cubic feet container to store the sargasso. We have named this second hopper barge Hopper 2. This modification implies both the replacement of the loading baskets and a greater height of the walls of the container, which serve as coamings to the hopper barge itself, avoiding the entry of large volumes of water in cases of strong waves during operations. Unlike Hopper 1, which must have a central longitudinal bulkhead and a transverse bulkhead also central inside the loading hopper, to avoid free surface effects and heeling that compromise the stability of the unit and can overturn the barge, Hopper may second, or may not have, depending on the operational area, a volume without divisions to locate the container inside the hopper. With this concept, an evaluation will be made of the impact of the increased height in relation to the design requirements of the sargassum collection feeding chutes and conveyor systems. The design of both hopper barges, Hopper 1 and Hopper 2, contemplates volumes of watertight compartments in the bow, stern, side tanks, and a double bottom that guarantee sufficient buoyancy in case of flooding of the cargo hopper by unforeseen strong waves when fully loaded with sargassum. It even assumes that in case of capsizing due to heel, the barge will have enough buoyancy reserve to avoid sinking. Finally, we included a larger hopper barge named Hopper 3 that can carry 16 freight containers fully loaded with sargassum, and its self-propelled version Hopper 4 as an alternative. Conclusions. Building upon the previous CSCA Euro integrated system submitted to SNAME and the lessons learned and further research throughout 2022 and 2023, our evolved ATSargassum family delivers a fully modular, scalable response to massive sargassum influxes. From asymmetric catamarans and advanced trimarans Euro, each optimized for uninterrupted, high-capacity collection Euro, to versatile tug-barge and self-propelled barge systems engineered for rapid deployment and seamless ship-to-ship transfers, every concept prioritizes operational efficiency, flexibility, and environmental stewardship. Complemented by our reinforced, container-based hopper barges with integrated ballast control and supported by dedicated Euro motorships Euro and real-time monitoring drones, These platforms can be combined in bespoke configurations to match any Bluma Euro trademark S scale and conditions. In doing so, ATSargassum empowers stakeholders with practical, cost-effective, and resilient sargassum management solutions precisely where and when they are needed most. Our motive: innovate, bringing new ideas and concepts.